Well, we're getting close to the end. We've got 2 chapters left. Chapter 5, Chapter 6. Chapter 5 is not a horrible chapter. The last section's the hardest section in Chapter 5. The first few sections, I think, are pretty friendly, so hopefully this is, kind of eases up a little bit if Chapter 4 was a little messy for you. So in Section 5.1, there's a handful of problems that in order to get from the beginning problem to the answer, you have to factor with fractions, and that's just not a skill that is horribly important. So I'm going to skip 31 through 38 and 57 through 62, and you can skip over those as well. If you're interested in learning how to factor with fractions, send me an email or come visit me, and I'll show you how to factor with fractions. But like I said, it's just not that important of a skill. So most every problem of the first 20 problems has an equal sign and an exponent of 2. And generally, when I see an equal sign and an exponent of 2, I think I should get 2 solutions. Usually, when you have an equation, you can get as many solutions as the highest exponent that you see, and that's going to be the case in most of the problems between 1 and 20. So I'm going to solve these problems using the square root property, which is the thing that's new to this section. The square root property is a technique for solving problems with equal signs that are set up exactly like this. On the left side of the equation, you have something squared. It could be more than just a letter. It could be a quantity in a parenthesis squared. And the right side of the equation is just some number. If you get them set up, the left side of the equation is something squared, the right side of the equation is a number, you can solve by square rooting each side. So I'm going to square root the left side, and I'm going to square root the right side. Unfortunately, that would only give me one solution. So in order to get the 2 solutions that are likely existing for this problem, I'm going to attach a plus or minus next to the square root symbol on the right side. Algebraically, square rooting cancels out an exponent of 2. So on the left-hand side, when I cancel out the square, I'm left with the y. On the right-hand side, this plus or minus symbol doesn't go away, but the square root of 25 turns into 5. And get the square root that I know without my calculator. But square root of 25 goes to 5. So I'm actually done, and this tells me that both positive and negative 5 are solutions. So this is probably the best way to write the answer to this problem. Because it's efficient and it's kind of common. Another way to write the answer would be y equal to 5 and negative 5. The plus or minus means both positive and negative 5 are solutions. And with this symbol, the plus or minus symbol, you need the plus sign. But I'm writing the 5 separately. You don't need the plus sign. We should check every problem, but the square rooting doesn't introduce extraneous solutions. So if I don't make a math error, then my answers are going to check. But it's not so hard to check. So the original problem was y squared equal to 25. I'm going to check to make sure that positive 5 squared equals 25, and that negative 5 squared also equals 25. When I'm using my calculator to check, if I'm squaring a negative number, that number has to be in a parentheses. If I don't put it in a parentheses, my calculator will give me the wrong answer. The positive, it doesn't really matter whether I do or don't. But I'll do both of them in a parentheses. Just, it's safer to use parentheses. So there's 5 squared. When I simplify the 5 squared, I get 25 equal to 25, so I know the first solution is okay. And similarly, when I do negative 5 squared, I get 25 equal to 25. So I know I've done perfectly and completely done with that problem. I expected to get 2 solutions because when you have an exponent of 2 as your highest exponent and an equal sign, you expect to get 2 solutions. And I checked, so I did everything I needed to do for that problem. Problem 4, I'm going to have my calculator in complex mode to check because it's going to give me an I, but I'm going to do the same thing. Let me write the problem a little bit bigger. So the problem is a squared equals negative 16. I'm going to square root the left side plus or minus the square root the right side to force my 2 solutions to happen. On the left side, square rooting cancels out a square, leaves me with the a. On the right side, I have my plus or minus symbol. And you have to make sure, if you're doing this on your calculator, that you have the complex mode. So you have to hit the mode button and type the number 2 for complex to make sure it can handle the square root of a negative number. I'm not going to enter the plus or minus sign, but I am going to enter the square root of negative 16, which is 4i. So my answers, this is the best way to write the answer. Again, it would be okay to say a equals to 4i and negative 4i. And I always should check. And since my calculator is so nice, it's easy to check. So the original problem is a squared equals negative 16. First I'm going to check the 4i. And then I'm going to check the negative 4i. So I'm going to go 4i quantity squared to see if that equals negative 16. And then do negative 4i quantity squared to see if that equals negative 16. So I have to check each solution separately. Because the solution is more than just a single number, I had to put it in a parentheses. And let me see how this works. So first one, 4, I hit the ENG key to get my I. Well, not that. And then squared, so there's the first solution checked. When I plug it in, I get negative 16. So it works there. And I'll do the other side. Do negative 4i squared. And that also gives me negative 16. So I've checked, I know my answer is correct. 24, I'm going to do exactly the same thing. I'm going to square root plus or minus square root. So on the left side, the square rooting cancels out the square symbol, leaves me with the d. On the right side, I can reduce the square root of 24 by hand, but by now I've reduced enough square roots, I'm kind of tired of doing it, so I'm just going to use my calculator to tell me how it reduces. But you could have done a prime factor tree for 24. If you did a prime factor tree for 24, it would have been 2 times 2 times 2 times 3. And it would have told me I get a 2 outside the radical and a 2 and a 3 under a radical. The 2 outside the radical looks just like that. The 2 and the 3 under the radical get multiplied to be a 6. This is the best answer. And again, you don't need to write the plus or minus symbol. That plus or minus symbol implies that both positive 2 square root of 6 and negative 2 square root of 6 are solutions. Again, I should always check. The original problem is d squared equal to 24. If I'm checking 2 square root of 6, I'm going to go parentheses 2 square root of 6 squared, see if that equals to 24. And then when I want to check checking d equal to 24. The original problem is d squared equal to 24. I checked positive 2 square root of 6. I also need to check negative 2 square root of 6 and see that negative 2 square root of 6 squared equals to 24. So quickly check. First one, 2 square root of 6 squared, and it equals 24, so that one's good. And then the second one, negative 2 square root of 6 squared also gives me 24 equals to 24. If I didn't have a calculator that did these so easily, the checking would be, in some sense a nuisance. If I had to check this by hand, I would have had to do this. I'd have to rewrite it as 2 square root of 6 times 2 square root of 6. So by hand is a little bit of a nuisance. Then I'd multiply the 2's, leave them outside the radical, multiply the 6's, leave them under the radical, and then the square root of 36 is 6, and 4 times 6 is 24. It would lead me to 24 equal to 24. I'm not going to check any of these by hand because that just slows me down too much. And I want the checking part just to be, 15 seconds, 30 seconds a problem. So up until 8, the problems are structurally the same. The left side has something squared, the right side has a number, and I don't see any parentheses. And in every one of those problems, I'm going to have a plus or minus in my best answer. So cross out the square with the square root. Don't use the plus or minus symbol, but I'm going to find out what the square root of negative 54 reduces to. It reduces to 3 times the square root of 6 times I. So that's the best answer. Again, if I wanted to do that by hand, to do the square root of 54, negative 54 by hand, the first thing I would do is make the 54 positive by introducing an I, and then I do a prime factor tree for 54, which is 2 times 3 times 3 times 3. And then outside the radical, I'd get a 3 from the pair of 3's. Under the radical, I'd get a 2 and a 3 from the single 3's that are left over, and that would give me 3 square root of 6i. I don't care to do that by hand. I've did a ton of those in the last chapter, so we should be good at that, and I'm going to take advantage of my calculator. I'm not even going to write the answer in both forms. I'm just going to call that my answer because it's the better way to write it. And then I'm going to check. So the original problem is x squared equals negative 54. I need to check 3 times the square root of 6i and negative 3 times the square root of 6i. So first one, I'm going to go 3 times the square root of 6 times I squared. Make sure that's negative 54. And then I'm going to do negative 3 times the square root of 6 times I and squared, and make sure that equals negative 54. Have to make sure when I enter the I, I'm putting the I not under the radical. I arrow out of the radical before I do it. So first one, parentheses 3 square root of 6, arrow to the right of the radical, hit the ENG button for the I, close my parentheses and squared, and that gives me negative 54 equals negative 54. And I'll do the same thing for the other side. So parentheses negative 3 square root of 6, arrow out of the radical, hit the ENG button for the I, parentheses squared, and I also get negative 54 equals negative 54. So when we're solving with square roots, if the squared term isn't in a parentheses, my best answer is going to have a plus or minus symbol. If when I'm solving with square roots, the squared number's inside a parentheses, I don't expect to see a plus or minus in my answer when the number to the right of the equal sign turns into the square root goes away. Let me just do this problem to show you what I mean. So this problem is a step up in difficulty more. It's just a little bit harder than the first few problems because it's an extra step. So I'm going to do the same thing. I'm going to square root and plus or minus square root. Anytime the left side, the entire left side is squared and the right side is just a number, the square root method is probably the best way to solve. So on the left side, the square rooting cancels out the square, and it just leaves me with the x plus 2. I don't need to write the parentheses anymore. I'm going to bring down the plus or minus sign. And then I could use my calculator, but I know the square root of 81 in my head, so I won't use my calculator. Now I need to solve for x because I don't have x solved for. So I'm going to minus 2 from both sides. And usually, we can't combine a term to the right of a plus or minus sign with a term without a plus or minus sign, or with anything, really. So I'm going to write the minus 2 just to the left of that plus or minus sign. I'm not done yet because these aren't two answers that are really that nice, and I could make it nicer. To make it nicer, I'm going to write the problem without the plus or minus sign. The problems that are implied by the plus or minus sign is x equals negative 2 plus 9 and x equals negative 2 minus 9. So my answer for this problem, even though I started plus or minusing, isn't going to be plus or minus the same number. The parentheses kind of messes that up. And so negative 2 plus 9 I don't need my calculator to do, but you can use your calculator if you don't. Similarly, negative 2 minus 9, I don't need my calculator as well. So for this problem, my answer doesn't even have the plus or minus symbol. My answer is going to be x equal to 7 and negative 11. And I'm going to check. So the original problem before I did anything was x plus 2 quantity squared equals to 81. I'm going to check x equal to 7 and see if 7 plus 2 squared equals 81. And I'm also going to check x equal negative 11 and see if negative 11 plus 2 squared equals 81. Those actually I could check in my head, but I'm going to do them by hand, by my calculator. So I'm going to go 7 plus 2 squared for checking the 7. When I check it, I get 81 equals to 81, so I feel good about that being a correct solution. I'll do the same with the negative 11. I'm going to go negative 11 plus 2 squared. Hopefully when I do that one, I also get 81, and I do. So I know that my answer is 100% correct. Anytime I see a square that applies to a letter, and I have an equal sign, if that 2 is the highest exponent that I see, I expect to get 2 solutions. I did, and I have to check each one separately. 12 is going to be a lot messier. There's potential for getting a fraction solution in number 12. So for 12, I'm going to do the same thing that I've done for every problem because it's still set up nicely for square rooting. The entire left side is being squared, and square rooting will cancel that square out perfectly. So on the left side, when I square root, I get 3x plus 7. On the right side, I have my plus or minus sign. And again, you can use your calculator to do the square root of 121 if that's not one that you know, but I know that that's 11. Now I'm going to solve this for x before dealing with the plus or minus sign. I'm going to minus 7 and get 3x equals minus 7 plus or minus 11. And then I'm going to divide by 3. And for those of you familiar with the quadratic formula, this is a kind of simplification that's going to come up when we do the quadratic formula. So that's not a very desirable answer, and this answer can be simplified if I make the separate problems from my plus and my minus. If I do x equal negative 7 plus 11 over 3 and x equal negative 7 minus 11 over 3, I can get nicer looking answers. So I'm going to break up the problem into the problems implied by the plus or minus. This one, you can do it on your calculator. If you can't get 4 over 3 without your calculator, you can go negative 7 plus 11 over 3. And my calculator tells me that that reduces to 4/3. I could do that in my head because negative 7 plus 11 is 4. For the other one, negative 7 minus 11 is negative 18. Negative 18 over 3 is negative 6. So again, if you couldn't do that by hand, you could go negative 7 minus 11 over 3, and it gives you the negative 6. So it looks like I have two answers, a nasty fraction of positive 4/3 and a nice negative number of negative 6. I need to check each. I don't have a lot of room. I'm going to just try to check it right up here. So first I'm going to check the x equal to 4/3. I'm going to go 3 times 4/3 plus 7 squared. See if that equals to 121. And then I'll do the -6. See if 3 times -6 plus 7 squared equals 121. So I'm going to check each separately. Hopefully they both come out real nice. So first one, parentheses, 3, then another parentheses and a fraction, 4/3. Error out of the denominator, parentheses, plus 7, another parentheses, and squared. So that looks enough like that one that I feel good about what I've typed in. And I get 121 equals to 121, so I know that answer, 4/3, is correct. Now I'm going to go down and check the -6. I'm going to go 3, parentheses 3, and then -6 in a parentheses, plus 7, parentheses squared. Again, that looks enough like that. I feel good about it. And I get 121 equals to 121 again. So I've checked, so I know both those answers are correct. So 14, structurally kind of the same way. It's actually a little bit harder, 14, because the 48, when it reduces, when you square root the 48, the square root symbol stays. So I'm going to go square root plus or minus square root. On the left side, square rooting cancels out a square, leaves me with the x minus 8. On the right side, the plus or minus symbol is going to stay, but the 48, when I square root it, is going to be 4 square root of 3. And I'm going to plus 8 to both sides. And get x equals 8 plus or minus 4 square root of 3. The two answers that are implied here are x is 8 plus 4 square root of 3 and x equals 8 minus 4 square root of 3. It turns out that you shouldn't get a 12 in the first solution. You shouldn't get a 4 in the second solution. I'll show you. My calculator's smart. It knows you can't add these. If I try to do 8 plus 4 square root of 3, my calculator says you can't add those, because in order to add terms, they have to have the same square roots. If this was 8 square root of 3 plus 4 square root of 3, I could get a 12 square root of 3. So that can't be added. I'm going to leave that just like that. And similarly, the second one, the 8 minus 4 square root of 3. I can't subtract the 8 and the 4 and get 4. If I try to do 8 minus 4 square root of 3, my calculator again knows that cannot be reduced. The only time you can add or subtract when you have square roots is if both pieces have the same square roots. So these are my answers, and it's in this case because this answer is really a shorthand. I can see both these answers looking at that answer. This is probably the best way to write the answer then, because when I break the problem up into the plus or minuses, that doesn't reduce like it did for the last problems, and I can see both answers embedded in that answer. So this is probably a nice way to write it. Whereas in the last problem, when I got to the plus or minus, when I look at x equals -7 plus or minus 11 over 3, I can't look at that and see that 4/3 and -6 are solutions, so it made sense to go further. But in this problem, when I look at breaking it up versus not breaking it up, I can see both those answers in the non-broken up version, and it's more efficient. So it's probably better just to leave it like that. But if you wrote the answers separately, that's okay. For checking, I have to understand both answers separately anyways. So for checking, I'm going to check that solution first. The original problem is x minus 8 squared equal to 48. So I'm going to see if 8 plus 4 square root of 3 minus 8 squared equals to 48. Notice I didn't put the 8 plus 4 square root of 3 in a parentheses. It wouldn't be wrong to have it in a parentheses, but because the x doesn't have a multiplication or an exponent associated with it, you don't have to put it in a parentheses. For the second one, my checking is going to look like this. I'm going to go 8 minus 4 square root of 3 minus 8 squared equal to 48. If I didn't have a calculator to do this, I wouldn't do the checking by hand. It's not hard, but it takes way too much time, and I'd likely make a mistake checking more so than not. So I'm trying to enter this first one the best I can. And again, for me, it's just not that hard to enter that. So I did 8 plus 4 square root of 3 minus 8 squared. And when I hit equals, I get 48. So that side works. Move over to the other side. 8 minus 4 square root of 3 minus 8 squared. Looks enough like that. Enter, and I get 48 equal to 48. So I'm going to say that both those answers are correct. And you could write them separately like this. You don't even need the two x's. If you wanted to, you could say the answers are 8 plus 4 square root of 3, x equal, and 8 minus 4 square root of 3. But there's not really any reason to do that when it's more efficient to write the plus or minus symbol, and the plus or minus symbol clearly implies that. 16's not going to be pleasant. I'm going to get a nasty square root in my answer. This is going to be a monster to check, but I'm going to do it anyway. So I'm going to square root plus or minus square root. The left side is easy because square rooting cancels out the square, makes it so I don't need the parentheses anymore. On the right side, I have the plus or minus symbol. Square root of 84 reduces to 2 times the square root of 21. I'm going to get it solved for x by minusing 9. I get 5x equals minus 9 plus or minus 2 square root of 21. And then I'm going to divide both sides by 5. I'm going to get x equals minus 9 plus or minus 2 square root of 21 over 5. That's a horrible solution. And the solutions that are implied are x equals negative 9 plus or minus 2 square root of 21 over 5 plus 2 square root of 21 over 5. And x equals negative 9 minus 2 square root of 21 over 5. And I'll show you that neither one of these reduce. So if I did the first solution, negative 9 plus 2 square root of 21 over 5, and I try to reduce that, my calculator says that doesn't reduce, so I'm not worried about reducing it. Similarly, if I did the second solution, fraction negative 9 minus 2 square root of 21 over 5, I get the same thing back. Well, it did something funky with the negative. It factored out a negative, which I would never do. But it doesn't reduce. You can't combine the 9 with the 2 square root of 21. You can't do anything with the 5 in the denominator. Factoring out a negative is something I didn't even know this calculator did. The 2 negatives in the numerator, it factored that negative out and made everything positive in the numerator. I wouldn't have programmed my calculator to do that. I like this better. So because the solution's written in their individual, with their individual solutions without the plus or minus, don't reduce, this is probably the better way to present the answer because it shows both those solutions just fine. Checking is really going to be unpleasant. I'm going to go to this problem, 5x plus 9 squared equals to 84, and I'm going to go 5 times fraction, in a parentheses, 9 plus 2 square root of 21 over 5 plus 9 squared, and see if that equals to 84. And I'll do the same with the other side. I'm going to go 5 times fraction negative 9 minus 2 square root of 21 over 5 plus 9 squared, and see if that equals to 84. So hopefully you're really competent with your calculator right now, because it's kind of a monster to enter, but it's kind of straightforward. So parentheses 5 parentheses fraction numerator negative 9 plus 2 square root of 21 denominator 5. Get out of that fraction, close the parentheses. So I'm getting there. I have the hard part in. Now I just need a plus 9, close my parentheses, and when I hit the square I might lose what I typed in, and you can't see the 5 anymore. But I've entered this nasty thing pretty nicely, and I reduce it, and it comes out to 84 just like it needs to be. So I know that I haven't made a math error. I get 84 equal to 84. Move over to the other side. Parentheses, 5, parentheses, fraction, negative 9 minus 2 square root of 21 over 5, close out my parentheses. So I'm getting there, and I just need to tack on the plus 9, close the parentheses, and square it. So plus 9, close the parentheses. I have everything but the square. As soon as I hit the square, you're not going to see this 5 anymore. Square equals, and it reduces to 84, equal to 84. If I had to do that by hand, I just wouldn't do it. But anytime I have a problem that has an equal sign and I get an answer, if it's checkable, I might as well check it. That way I know that my answer is right, and I'm not going to lose any points when it comes to a test. 18 and 20, I would be shocked if they ever made their way onto a test in my class because of the fraction inside the parentheses. So if you felt the urge to fast forward and move on to the other problems in the next grouping, it's okay. But watching it can't hurt you. Doing it would even be better. So square root plus or minus square root. Left side I get x minus 1/2. Right side, the plus or minus symbol doesn't go away. The square root of 16 I can do without my calculator and know that that's 4. Add 1/2 to both sides. I get x equals 1/2 plus or minus 4, which is x equal 1/2 plus 4, and x equals 1/2 minus 4. Those, I think, can be added together. I can do them by hand. To do 1/2 plus 4, I'd write the 4 as 4 over 1. I'd multiply it by 2 over 2 and make it 1/2 plus 8/2. This side's going to come out to be 9/2. My calculator makes it way easier, so I'm going to do it on my calculator and go fraction 1/2 plus 4, and my calculator gives me 9/2 that I could have gotten by hand. And then the other 1/2 minus 4, again, I could do it by hand, but I make more mistakes by hand than I do pressing buttons. So because the solutions look quite a bit different when I break the plus and minus and simplify, my answer shouldn't have the plus or minus symbol in it. So my answers should have the individual number. Should be x equal to 9/2 and negative 7/2. Now I'm going to check. No, didn't leave myself a lot of room. So the original problem, if I put 9/2 in, I'm going to go 9/2 minus 1/2 squared, see if that equals to 16. And then if I change the x to negative 7/2, I'll go negative 7/2 minus 1/2 squared and see if that equals to 16. So again, not something I'd probably check by hand, but my calculator makes this kind of, in some sense, effortless. So 9/2 minus fraction 1/2, close out my parentheses, square. That's checking the 9/2. When I hit enter, it best say 16. Because it does, I know 9/2 is a solution. And now I'm going to do the same thing for the 7/2. I'm going to go parentheses, fraction, negative 7/2 minus fraction 1/2, close out my parentheses, square, and make sure I get 16 again. And since I do, I know that both of my answers of 9/2 and negative 7/2 are correct. And I shouldn't have the plus or minus in my solution because I can't look at the plus or minus and quickly tell that it equals 9/2 and negative 7/2. Whereas in the last problem, because when I broke the plus and minuses up into their separate problems and entered both of these on my calculator, they didn't simplify. I can tell these two answers by just looking at that answer, so it's better to have the plus or minus symbol. Last one in the first grouping of problems, really, really unpleasant problem in terms of checking. So I'm going to go square root plus or minus square root. Left side gives me y minus 1/5. The right side, if you try to reduce the square root of 19 on your calculator, it's not going to reduce. If I just did square root of 19, it's 19 is a prime number. It's not a reducible square root, so I can't improve upon that square root of 19, but I can get the 1/5 over to the right side. This gives me y equals 1/5 plus or minus the square root of 19. You can't add something without a square root to something with a square root, so this is probably going to be the best answer. But when I check, I need to show the individual answer. So the y equals 1/5 plus the square root of 19, and y equals 1/5 minus the square root of 19 is what I'm going to check. I'm going to go to the original problem and do 1/5 plus the square root of 19 minus 1/5 squared, and see if that one equals 19. That's just changing this y to that one, to the answer. And because that y doesn't have a multiplication associated with it or an exponent, I don't really need to put the ugly answer in a parentheses. And for the other one, I'm going to go is 1/5 minus the square root of 19 minus 1/5 squared. Does that equal to 19? So I'm going to check both of them because I can. Parentheses, fraction 1/5 plus square root of 19 minus fraction 1/5. Close out my parentheses, square it, and I get, wonderfully, 19 equals to 19. And on the other side, parentheses, fraction 1/5 minus square root of 19 minus fraction 1/5. Close out my parentheses and square, and I get 19 equals 19 as well. So I've checked every single problem between 1 and 20, and it's not that hard to do. You should do that. The middle group of problems is where we're going to start skipping some. So in these problems, I'm only going to do from 21 to 30, and I'm going to skip the 31 through 38. These problems, once we get into them, you're going to see that they involve factoring, and 31 through 38 would involve factoring with fractions, which just isn't something we really need to worry about. It's not that important of a skill. It doesn't really come up in Math 151, so it's not something I want to just kill you with. So the instructions for these problems basically says replace the c with a number so that when you factor the result, you get two identical parentheses. And this method of changing a c to a number is called completing the square. So the number that's going to work for c, we usually say that c equals half the middle terms squared. In this particular problem, my goal is to replace this c with a number. And the number that I'm going to replace it with is going to be half of the number in front of the middle term. The number in front of the middle term is 8. Half of 8 squared. I can do that without my calculator. I'll do it by hand and then with my calculator. Half of 8 is 4. 4 squared is 4 times 4 is 16. Let me show you this on my calculator. On my calculator, to do what c is, I'm going to go fraction, a parentheses fraction, 1 over 2 times 8, close my parentheses, really, I don't know what I just did there, close my parentheses and x squared, and I get the same 16. So I take the number in front of the first power term, find half of that number, and then square that result, and I'm going to change the c to that number. And now I'm going to factor. So first I found a value of c, so the expression becomes a perfect square. That's what I've done right now. I found a value for c, and now I'm going to factor. So when I go to factor this, I know that I don't need bottoms up because there's not a number in front of the b squared, that my signs are pluses and pluses because there's no numbers, no minus signs, and my lasts, they could only be 1 and 16, 2 and 8 are 4 and 4. They need to give me that 8, and the 4 and 4 are going to be the pair that works. And now I've shown that this is called a perfect square, because when something factors in its parentheses are identical, we call that this b squared plus 8b plus 16 is considered a perfect square. And it's better to write any perfect square with an exponent of 2. It's more efficient. It turns out that the problems between 21 and 30 that we're going to do, there won't be a question that has exactly these instructions. So this skill is helping us for when we get to problem 39 and higher. So in terms of writing an answer, I might say c equals to 16 and comma b plus 4 squared, because I found my value of c and I factored the result after I changed the c to that number. So I'm going to do 24, 26, 28, and 30. And then this skill is going to come back in the bottom group of problems. Like I said, nothing between 21 and 30 is going to make its way directly on the test, but this skill is going to come up in the last group of problems in this section. So for 24, to find out what c equals, c has to equal half of the number in front of the x to the first power term squared. I can do this without my calculator, but if you need your calculator, it's fine. Half of 16 is 8. 8 squared is 64. Let me double check to see that. Parentheses 1/2 times 16 squared. It equals to 64. So I'm going to change the c to a 64. I'm going to go x squared plus 16x plus 64. Now, that's the first part. So part of my answer, I'm going to say is c equal to 64. The rest of my answer is what this factors into. And I don't need bottoms up because there's not a number in front of the x squared. I don't need any minuses because there's no minuses in the problem. My numbers have to multiply to 64 and add to 16. So I could do 1 and 64, 2 and 32, 4 and 16, 6 doesn't work, or 8 and 8. All those numbers multiply to 64. I need the pair that add to 16, and it's the 8 and 8. And in these problems, it's always going to be the pair that's always going to work is the matching pair, the square root of this number, or the half of the 16, or the half the 8 went into the parentheses there. So this guy, if you FOIL this back out, you'd get the line above it. I'm not going to take the time to check that because it's already getting to be longish, the video. So and these problems aren't directly on the test, so I'm not going to do that much with them. That's everything that's asked from problem 24, though. I want to replace the c with a number, factor, and stop. 26 is a little bit harder because of the negative, but it's not that much harder. So c is going to equal to half of negative 12 squared. By hand, half of negative 12 is negative 6. Negative 6 squared is negative 6 times negative 6, which is positive 36. I'm going to double check myself. So parentheses, fraction, 1/2 times negative 12, close the parentheses and square. I get 36. So I'm going to write this as d squared minus 12d plus 36 is always plus c. And then for factoring, the signs are a double minus. So the factors that I need are a double minus. So I can do -1 and minus 36, -2 and minus 18, -4 and minus 9, or -6 and minus 6. I need the pair that gives me that minus 12. And that's the case that the -6 and minus 6 are going to work. So after the d's, I'm going to put a couple of -6's. And for my answer, I'm going to say c equals to 36. And this thing factors into d minus 6 squared, because d minus 6 times d minus 6 is equal to d minus 6 squared. Okay, that's everything that needs to be done. If I wanted to, I could FOIL this back out to make sure I factored it right, but I'm not gonna. 28, same problem. So C is half of negative 20 squared. Half of negative 20 is negative 10. Immediately, this is a number that's going to go in my factoring. That's the number that's going to go in each parentheses. Each parentheses is going to have a minus 10. Just like in the last problem, each parentheses had a minus 6. 2 problems ago, each parentheses had a plus 8. And the first problem in this grouping, each parentheses had a plus 4. So when you're doing this C, it's really constructive because it tells you the number that goes in the factoring, because each parentheses is going to get the same number, and it's going to be that number before you square it. So when I do this problem, I change it to y squared minus 20y plus 100, and then the minus 10 is going to go in the parentheses when I factor. So this is going to factor. Y's are firsts, my lasts are a couple of minus 10s, because the minus 10s multiply to 100 and they add to negative 20. So for an answer, and I sped through this and didn't use my calculator because I wanted to get onto the things that are test worthy, the answer is going to be C equal to negative 10, and this whole thing factors into y minus 10 squared. So one more of these, and I don't think it's that new. This exactly. I changed this problem just this semester because this was a fraction problem. Oh, this is exactly problem 30. Let me change this, and then I'll change it so you don't see this problem again. How about this? B squared plus 14b plus c. So that will be, when you print it out, that's what you're going to see for that problem. So find C. C is half of 14 squared. Half of 14 is 7. 7 squared is 49. So I'm going to change this problem to b squared plus 14b plus 49, and then I'm going to factor it. I know that my firsts have to be a couple of b's. There aren't any minus signs, so I need a couple of pluses. And my lasts need to multiply to 49 and add to 14. And 7 do that perfectly, because 7 times 7 is 49. 7 plus 7 is 14. So my answer to this problem, I'm going to say C equal to 7, and this whole thing factors into b plus 7 quantity squared. Okay, those aren't test worthy, but that strategy of finding the C is what the instructions ask in the next group of problems. You'll see I skipped the problems from 32 on. If I did this problem, this is not on the test, but if I did this problem, I'd go C is half of 9 squared, and fraction half times 9 squared. You'd get 81 over 4, and you'd get b squared plus 9b plus 81 over 4. And then factoring with a fraction isn't something that we never have to do, really. This actually factors because this multiplication, 1/2 times 9 is 9 halves. This factors into v plus 9 halves times v plus 9 halves. And my answer for 32 would be C is 81 over 4. This thing factors into v plus 9 halves squared. But none of the problems between 31 and 38 you're not responsible for. And specifically, you're not responsible for them because in the factoring, you'd have a fraction to factor with, and we never factor with fractions. And similarly, 57 through 62, they have the same problem where the factoring would have fractions, and that's not something we're going to be responsible for. So, last group of problems, of which we're going to skip, we're only going to go from 39 to 56, because we're skipping 57 through 62 because they would involve factoring with fractions. The instructions, all I have to say is this: solve by completing the square, and that calls out this strategy. So, and I tried to be more specific. I said, to solve this problem, we want to rewrite the equation so it can be solved with square roots. That is, find a c, like we did for problems 21 through 38, rewrite both sides. So what I'm going to do is this. I'm going to change this problem to be 8b squared plus 8b plus c. And now because I have two sides to keep my equation balanced, I have to put a c on the right side. So I'm going to change these problems to look like the beginning problems or the middle problems that had the c's. And I'm going to find a value for c, and I'm going to add it to both sides of the equation. So in this problem, the c is going to be half of 8 squared. Half of 8 is 4, and 4 squared is 16. So for this problem, I'm going to introduce a c. Because I have an equal sign to keep the equation balanced, I have to put it on both sides. So I'm going to go b squared plus 8b. I'm going to change the c to 16 on both sides. So the problem didn't start off with a c, but completing the square requires me to solve with a c. So I introduce the c to both sides. I'm going to simplify each side. I'm going to factor the left side. And on the right side, I don't need my calculator to know what 9 plus 16 is. It's 25. On the left side, I'm going to factor. I know my first are a couple of b's. My signs can't have any minuses because there aren't any minuses in the problem. And my last have to multiply to 16 and add to 8, and that's going to be a couple of 4's. So I'm going to put a couple of 4's after the b's, and I'm going to rewrite that as b plus 4 quantity squared. So what I've done, I'm in the midst of solving by completing the square. So I'm rewriting the equation so it can be solved like the beginning problems. So I added a c to both sides. I changed a c to a number so the left side would factor into a perfect square. Now I've transformed this problem into something that looks like the beginning problems, and I'm going to solve it by square rooting, plus or minus square rooting. On the left side, I'm going to get b plus 4. On the right side, I'm going to get plus or minus 5, because the square root of 25 is 5. I'm going to minus 4, and get b equals minus 4 plus or minus 5. The two problems implied there are b equals minus 4 plus 5 and b equals minus 4 minus 5. I can do both on my calculators if I'm not comfortable doing this in my head. Minus 4 plus 5 is positive 1. Minus 4 minus 5 is minus 9. So I took a lot of space here. The answer to this problem, I believe, is b equal to 1 and minus 9. I should always, when I get an answer to a problem with an equal sign, check. So I'm going to check one at a time. The original problem was b squared plus 8b equals 9. That's what I should check into. I shouldn't check into anything after the original problem, because if I made a mistake on my first step, it wouldn't show up. The first one I'm going to check is 1 and see if 1 squared plus 8 times 1 equals to 9. And then I'm going to check my negative 9 and see if negative 9 squared plus 8 times negative 9 equals to 9. I'm going to check each one separately to make sure I haven't messed up. So first one, 1 squared plus 8 times 1. And hopefully I see a 9 when I do that, and I do. So for the first, checking the 1, it reduces to 9 equal to 9, so I know my answer is right. I'll do the negative 9 now. So I go negative 9 squared plus 8 times negative 9, and see if that equals to 9. Because each number substituted back into the original equation gives me a true statement. I know my answer is correct. So this is everything in the bottom group of problems, other than sometimes I'm going to have to, before I add c, get the letters and the numbers separated. And that might come right up in 42, and it does. So in 42, before I'm going to add c to both sides, I need to have the letters and the numbers separated. So I'm going to get the 16 to be by itself. So for all the bottom problems, the C method for solving requires the problem to be set up with the letters on the left side, the number on the right side. Now I'm going to add C to both sides. So I'm going to go y squared plus 6y plus c equals 16 plus c. That keeps the equation balanced, but it gives me something I don't know what to do with. So I'm going to find out what to change c to. C is going to be half of 6 squared. I could do that on my calculator if I'm not comfortable doing that by hand. Half of 6 is 3. 3 squared is 9. So I'm going to go y squared plus 6y plus 9 equals 16 plus 9. I'm changing the c's to that 9. I'm going to factor the left side. Always the number in the parentheses comes in my factoring. It comes in both parentheses. So since I did the c correctly, it's going to be easy to factor. The left side, I get a couple of y's. Signs have to be pluses because there's no minuses anywhere in the problem. My last need to multiply to 9 and add to 6. That's going to be 3 and 3. Right side, 16 plus 9 is 25 again. I'm going to rewrite the left side as y plus 3 quantity squared. And I'm going to solve with square roots now. So this is called solving by completing the square. When you take a problem that you couldn't solve with square roots and you turn it into a problem that you can solve with square roots, that's what completing the square does. So square root plus or minus square root. Left side, the square rooting cancels out the square, leaves me just with the y plus 3. Right side, I don't need my calculator to know the square root of 25, but you certainly can use your calculator if you're not good at doing square roots. On the left side, the 3's cancel. On the right side, I'm going to make up two problems that are implied by the plus or minus symbol. Negative 3 plus 5 and negative 3 minus 5. Again, if you can't do these nicely, you can use your calculator. The negative 3 plus 5 is 2. The negative 3 minus 5 is negative 8. So I believe my answer is going to be y equal to 2 and negative 8. I should check in the very original problem. So for checking the 2, I'm going to go to the original problem and see if 2 squared plus 6 times, I don't need the 6 in a parentheses, I need the 2 in a parentheses. 2 squared plus 6 times 2 minus 16. See if that equals to 0. So that's just going to the original problem. I always, when I check, I go to the original problem, take my answer and plug it in for the letter, and try not to do it that horribly. So here, 2 squared plus 6 times 2 minus 16. When I hit enter, because I get 0 and the right side is 0, I know that positive 2 is the correct solution. Checking the negative 8, I'm going to see if negative 8 squared plus 6 times negative 8 minus 16, see if that equals to 0. So again, I'm going to just use my calculator. Minus 8 squared plus 6 times negative 8 minus 16. Hopefully when I hit enter I see 0, so I know I haven't made a mistake. And I do. So I'm done. I've done the prescribed method, solved using C's, or completing the square, and I've checked my answers. So 44, nicer problem because I can go straight into adding the C's because the letters are by themselves on the left side and the number is on the right side. So C is going to be half of negative 6 squared. Half of negative 6 is negative 3. That negative 3 is going to come up in the factoring in both parentheses. And negative 3 squared is negative 3 times negative 3, which is positive 9. So I'm going to rewrite this as y squared minus 6y plus 9 equals 7 plus 9. And now it's real easy for me to factor because I just look at that number in the parentheses. That's going to go in both of my factors. My signs have to be double minus. My lasts need to multiply to 9 and add to 6, and the double negative 3s are going to do that perfectly. So this is going to factor now into y minus 3 times y minus 3. If you FOILed it back out, you'll see the lasts multiply to 9. The outers and the inners are both negative 3y, so that give me the negative 6y. I'm going to rewrite the problem so it has an exponent so I can solve with square roots. So I took the time, I introduced the c, found out what c was, added it to both sides, factored, and now I'm going to square root plus or minus square root. On the left side, you get y minus 3. On the right side, you get plus or minus 4. Now I'm going to add 4 to both sides. And I get y equals to 4 plus or minus 4. Make up the two problems, y equal to 4 plus 4. Really? Oh, I'm adding 3 to both sides. Plus 3 plus 3. And I get y equals to 3 plus or minus 4. Sorry about that. I don't know why I added 4. I should have added 3 here. And I started to do the math in my head, figuring I was screwing up. So it should be y equal to 3 plus 4, which is 7. And y equal to 3 minus 4, which is negative 1. Should always check. So I'm going to check the 7 to see if 7 squared minus 6 times 7, see if that equals to 7. And then also check the negative 1, see if negative 1 squared minus 6 times negative 1 equals to 7. So first one, 7 squared minus 6 times 7. That gives me 7 equal to 7, so I know that 7's the correct answer. Second one, negative 1 squared minus 6 times negative 1. That also gives me 7 equal to 7, so I know my answers are correct. Now I'm going to write down my answer. My answer is going to be y equal to 7 and negative 1. 46. I'm not ready to add the c's because the numbers and the letters are on the opposite sides. So I'm going to go ahead and do that first, just like I did a few problems ago. I'm going to minus 3 from both sides. And when I do that, I get y squared minus 4y equals minus 3. If I don't have the numbers and letters on opposite sides, the c method doesn't work so well. So now I'm going to add c to both sides to keep the balance. You can't just add c to one side, otherwise you mess up the equality. Find out what c is. C is half of negative 4 squared. Half of negative 4 is negative 2. That negative 2 is going to come on my factoring. It's actually negative 2 squared. Negative 2 squared is a positive 4. So I'm going to change this to y squared minus 4y plus 4 equals negative 3 plus 4. Easy to factor this left side because I'm going to get two identical parentheses, and I know the number has to be a negative 2 in both parentheses because my lasts have to be double minus. I have to multiply to 4, add to negative 4, and the double negative 2 will do that. The right side, negative 3 plus 4 is 1. So this simplifies to y minus 2 squared equals to 1. And now I'm going to square root plus or minus square root. On the left side, I get y minus 2. On the right side, 1's a sneaky square root. It's its own square root. The square root of 1 is just 1. So I get y minus 2 equals plus or minus 1. I add 2 to both sides and get y equals to 2 plus or minus 1. I make up the problem y equals to 2 plus 1, which gives me the 3, and y equal to 2 minus 1, which gives me the 1. Want to check each before I go and commit to an answer. So for the 3, I'm going to go 3 squared minus 4 times 3 plus 3. Make sure that equals to 0. So I want to check in the problem before I did anything to it, just in case I made a mistake on my first step. And for the 1, I'm going to go 1 squared minus 4 times 1 plus 3 and make sure that equals to 0. So first one, 3 squared minus 4 times 3 plus 3. That gives me 0 equal to 0, so that's good. Second one, 1 squared minus 4 times 1 plus 3. That gives me 0 equal to 0. So both solutions, when I checked them, gave me a true statement, so I know both the answers work. And so for my answers, I'm going to say y equal to 3 and 1. I imagine we're going to start running into problems that have ugly square roots in their answers real quickly. And that's going to be possibly right now. I'm not certain 100% that this one's going to have an ugly square root. It might have an unpleasant I in it. So this problem is set up perfectly to give me the c. So I'm going to add c to both sides. I'm going to figure out what c is. C is going to be half of 8 squared. Half of 8 is 4. That 4 is going to come in the factoring. 4 squared is 16. So I'm going to get b squared plus 8b plus 16 equals 4 plus 16. Left side is going to factor. The number inside the parentheses is going to be in both my factors. This is going to factor into b plus 4 times b plus 4, because the last will multiply to 16 and add to 8. Right side is 20. That's really not good in terms of everything's going to go downhill from here. So now I'm going to go square root plus or minus square root. Left side I get the b plus 4. Right side I get the square root of 20, and although I can reduce it without my calculator, I might as well use my calculator because it does it so much quicker. So I get 2 square root of 5. I'm going to minus 4 and get b equals minus 4 plus or minus 2 square root of 5, which is minus 4 plus 2 square root of 5 and minus 4 minus 2 square root of 5. You'll see that both of these, if I did minus 4 plus 2 square root of 5 and I tried to reduce it, it doesn't reduce. Similarly, minus 4 minus 2 square root of 5, also you can't reduce. You can't combine the minus 4 and the 2 or the minus 4 and the minus 2 because they both don't have square roots. So because these answers written individually don't simplify, this, if these are correct, will be the best answer right here. So I'd leave my answer with the plus or minus sign because the answers written separately are not reducible, and I could see both of those answers in that answer. Checking is going to be horrible. So for the first one I need to go is negative 4 plus 2 square root of 5 squared plus 8 times negative 4 plus 2 square root of 5. Does that equal to 4? And then for the other side I'm going to go, does negative 4 minus 2 square root of 5 squared plus 8 times minus 4 minus 2 square root of 5 equal to 4. So I want to change each of my b's in the problem before I did anything to it to these horrible answers, and I'm going to check. So first one, parentheses, negative 4 plus 2 square root of 5 squared plus 8 times negative 4. So I'm going to start losing this, so you're not going to see it anymore, but it's going to be just off the screen, plus 2 square root of 5 parentheses. Entered that side, I think, perfectly, and it reduces to a true statement, so I know that's an answer. I'll check the other one best I can. So the other one I'm going to go parentheses minus 4 minus 2 square root of 5 squared plus 8 times parentheses minus 4 minus 2 square root of 5. Close out my parentheses, and it also reduces to 4 equal to 4. So there's no reason in this section for anything that's going to make its way onto the test to write down the wrong answer, because you can check every answer. And the problems that come on the test are the beginning problems where we're just able to do square roots. The middle problems where they gave me the C, those aren't on the test. And then the last group of problems between what we're going to do between 39 and 56, those are on the test. So the beginning and the last problems are on the test, the middle problems aren't. 50 isn't set up to handle my c's, so I'm going to get it ready to handle my c's by getting the numbers on one side, the letters on the other. So I'm going to minus 24 from both sides and get x squared minus 6x equals to minus 24. I'm going to add c to both sides. I go x squared minus 6x plus c equals to minus 24 plus c. Find out what the c is. C is half of negative 6 squared. Half of negative 6 is negative 3. That negative 3 is going to come up in both parentheses. Negative 3 squared is 9. So I'm going to write this as x squared minus 6x plus 9 equals negative 24 plus 9. The left side, I know the signs are a couple of minuses, and I actually know the numbers are a couple of minus 3s. I'm not even going to question that. And the minus 24 plus 9, I think I get a minus 15. So minus 24 plus 9, I get a minus 15. Ugh. So I get x minus 3 squared equals minus 15. Then I square root plus or minus square root. Left side I get x minus 3. Right side, the square root of minus 15, it's going to have an I outside the square root, but other than that it isn't going to reduce. So this is going to equal to plus or minus the square root of 15 times I. I'm going to add 3 to both sides, and I get x equal to 3 plus or minus the square root of 15i. And that means 3 plus the square root of 15i and 3 minus the square root of 15 times I with the I outside the radical. Those can't be simplified. If I enter these on my calculator, it's just going to give it back to me. If I do 3 and the square root of 15i, not under the radical, you have to get out of the radical for the I, it doesn't reduce. So because neither one of the solutions written without the plus or minus sign reduces, I think this is my answer, but I'm going to check, and I really don't want to, but I'm going to do it anyway. So I'm going to go to the original problem and go first 3 plus the square root of 15, make sure to get that I outside the radical, squared, minus 6 times 3 plus the square root of 15, make sure to get the I outside the radical, plus 24, and see if that equals to 0. So this is not going to be pleasant, but I'm going to do it. So can you see this here? Kinda. So first I go 3 plus square root of 15, arrow out of the radical, get my I, parentheses squared, and then minus 6 parentheses 3 plus the square root of 15, get out of the radical, I, close my parentheses, plus 24. You can't even see it, but I did it hopefully correctly. And this reduces to 0 equals to 0, so that one's okay. And now I'm going to do the same thing. I'm just going to change that to a minus and that to a minus. Don't have a lot of room to write it, but I'm going to check it with the minuses. So with the minuses, I'll go 3 minus square root of 15, I outside the radical, parentheses squared, minus 6 parentheses 3 minus as opposed to plus square root of 15 I plus 24. When I do that one, I also get 0 equal to 0. So I've checked both my solutions. I know they're right. So 3 more problems to deal with. 52 is already set up for the C's, so I'm just going to kick those C's straight in. I'm going to go y squared plus 10y plus c equals 12 plus c. C is going to be half of 10 squared. Half of 10 is 5. That 5 is going to come up in my factoring. 5 squared is 25, so I'm going to write y squared plus 10y plus 25 equals 12 plus 25. Left side, I know it factors. I don't need minus signs because there's no minus signs in the problem. The number inside the parentheses before I square it when I'm solving for the c goes in each, because 5 times 5 is 25, 5 plus 5 is 10. Right side I can do without my calculator. So So I get y plus 5 squared equals to 37, square root plus or minus square root. This gives me y plus 5 equals plus or minus the square root of 37. You can try that in your calculator. It won't reduce because 37 is a prime number. And then minus 5 gives me y equals minus 5 plus or minus the square root of 37. That would be the best answer if they check. So I'm going to check negative 5 plus the square root of 37 for y, and negative 5 minus the square root of 37 by going negative 5 plus the square root of 37 squared plus 10 times negative 5 plus the square root of 37, and see if that equals to 12. And then I'll do the other one with the minus, and I'll do it right in line. So first checking is going to be parentheses negative 5 plus the square root of 37 squared plus 10 times negative 5 plus the square root of 37. When I hit enter, better equal 12 because the right side is 12. It does, so I've checked the one with the plus. Now I'm just going to change these pluses to minuses and do the same thing. So I'm going to go negative 5 minus square root of 37, arrow out of the square root, parentheses squared, plus 10 times negative 5 plus the square root of 37, arrow out of the parentheses, square root in parentheses, and oh, I don't see a true statement there. That's not comforting, but maybe I made a mistake on my calculator. I might have blew the sign, I might have just, so this is bad, but let me recalibrate. I think I probably just messed up on my calculator. So let me try this again. Negative 5 minus the square root of 37 is what I'm checking this time, squared, plus 10 times negative 5 minus the square root of 37, arrow out. It was just a calculator error. Because I'm trying to be slick and not write down each thing that I'm checking, I probably blew a sign. I entered a plus sign once and a minus sign in the other. The signs had to be the same because the solutions have either, both plus signs or both minus signs. Well, for the 37 part, should I say. So it's just a calculator error. I'm wearing out, so that means you have to be completely worn out. Make the c appear. X squared minus 6x plus c equals negative 4 plus c. C equals half of negative 6 squared, which is negative 3 squared, which is positive 9. So I get x squared minus 6x plus 9 equals negative 4 plus 9. Left side's going to easily factor. This number in the parentheses comes in both parentheses. It factors into x minus 3 times x minus 3. Right side I can do without my calculator. It's 5. So I get x minus 3 squared equals to 5. Square root plus or minus square root gives me x minus 3 equals plus or minus the square root of 5. Plus 3 plus 3. Best answer, because these things aren't going to simplify in their when you separate the plus or minus, would be that. Can't add something outside a square root with something under a square root. Now I'm going to check x equals 3 plus the square root of 5 and x equals 3 minus the square root of 5. So I'm going to go, does 3 plus the square root of 5 squared minus 6 times 3 plus the square root of 5, does that equal negative 4? And then I'll do, does 3 minus the square root of 5 squared minus 6 times 3 minus the square root of 5, does that equal negative 4? Because that's what it needs to do to check. Parentheses, 3 plus square root of 5 squared minus 6 times 3 plus square root of 5. That's the first one. You can barely see what I wrote in, but when I check it, I get negative 4 equals to negative 4, so that's valid solution. Second one, parentheses, 3 minus square root of 5 squared minus 6 times 3 minus square root of 5 equals, and I get a lovely match that I needed to get. So I checked my solution so I know I haven't made a mistake. Last one. This one's probably going to have an I in it again. So write it as y squared minus 6y plus c equals negative 16 plus c. C equals half of negative 6 squared, which is negative 3 squared, which is positive 9. Rewrite this as y squared minus 6y plus 9 equals negative 16 plus 9. Left side super easy factoring because I know the number that goes in the parentheses. I know the parentheses have to be identical. Right side I can do that without my calculator. So I get y minus 3 squared equals negative 7 square root plus or minus square root. Left side is y minus 3. Right side, if you did it on your calculator, it would kick in an I outside the radical because of the negative under the square root. Add 3 to both sides. If these check, they're the best answer. Y equals 3 plus or minus the square root of 7i. Checking, I need to check y equals 3 plus the square root of 7 times I, and y equals a 3 minus the square root of 7 times I. First one, I'll go 3 plus the square root of 7 times I squared minus 6 times 3 plus the square root of 7 times I. Hopefully I get negative 16. Second one, I'll do 3 minus the square root of 7 times I squared minus 6 times 3 minus the square root of 7 times I. Hopefully that also gives me negative 16. So last thing for the section. Checking this one. I do parentheses 3 plus the square root of 7, arrow out of the square root, ENG button for the I, parentheses squared minus 6 parentheses 3 plus the square root of 7, arrow out of the parentheses, ENG for the I, close my parentheses. When I hit equals, hopefully I see negative 16, which I do, so I know the first one is the correct solution. I'll check the second one now. 3 minus the square root of 7, I outside the radical, squared, minus 6 times 3 minus square root of 7, I, close out my parentheses. Hopefully I see another negative 16, which I do. So I've checked every single answer, which is a nice luxury when you have a calculator that's easy to use and you have problems with equal signs. So hopefully you do well on the homework. Because this is a short chapter, there's only 5 sections, so each section's going to have more problems than it might normally in a longer section. So hopefully you can rock these problems, and if you're not feeling good about anything, you can always come visit me, shoot me an email, and I can sit down and help you as long as you need to understand them. Thank you.